Okay, here we are on day 37 lessons. So we're going to jump right to the math boxes, and that's the math windows on page 5 of 11. Doesn't mean you should skip the other exercises. They're good practice for you to get ready for the test. Okay, number 1. So they give us a list of numbers, and they're asking us for the mean, the median, and the mode. Okay, so which is which? Well, the mean, I try to remember that the mean is the meanest one, is the hardest one to find. Another word for mean is average. Well, we're going to skip that one for now, and we're going to do the median. Okay, the median is the one that comes in the middle when they're arranged in order. So let's arrange them in order. You've got 1, you've got a 2, you got a 3 and another 3, so we'll put 2 3s. 3 4s over there. 3 4s, a 5, and an 8. Let me just check 1, 2, 3, 4, 5, 6, 7, 8, 9, 1, 2, 3, 4, 5, 6, 7, 8. Yes. So which one would be in the middle? Well, out of 9, the fifth one should be in the middle. 4, 4. Here's the fifth one. The middle one is 4. That's the median. The median is the one in the middle if you line them all up. The mode is the one that occurs most often. Again, that's 4. There's 3 of those. It occurs the most of any of them. 4s do. The mean, so the mean, you want like an average of all those numbers. And how do you figure out the average? Well, you add them all up and you divide by how many numbers there are. So you could use your calculator, but I got 1 and 2 is 3, and 3 is 6, and 3 is 9. 3 4s is 12, so 9 and 12 is 21. 5 and 8 is 13. 21 and 13 is 34. Now, if this were a test, I'd check it over going this way. 5, 13, and 4, 17, 21, 25, 28, 31, 33, 34. I got it 34 2 times. And I'm going to divide that by 9 numbers. Okay, 34 divided by 9. Well, if you use your calculator, oh, here I go. Here's my calculator. 34 divided by 9 equals, let's see if that came out, 3.777, 3 and 7 ninths. I'll use the fraction one, 3 and 7 ninths. 3 with 7 left over, 3 and 7 ninths. Okay, moving on. Yikes. The table shows employees' yearly pay at Village Digs Vintage Clothing Store. So here's the employees and how much they get, yearly wage. At the end of each year, by the way, I hope you try these again before you look at my solutions. You should be trying them if you can, because that's getting ready for the test, is practicing these on your own. The solutions are just to help you see how it was done in case you weren't able to do it, or to check and see if you got it right. At the end of each year, each employee will get a 4% cost of living pay increase. For meeting sales goals, each employee will also get a raise equal to 1% of the total sales for the year. If the sales total this year is $234,000, what will Rena's new yearly wage be? Okay, let's look at the answers here. Well, these are all big numbers. That's a real small number. What is it asking? What is her new yearly wage? What's her new pay going to be? She's already getting $23,000. Do you think she's going to get $3,000 as her new wage? She'll quit if she's going to get $3,000 as her new wage. So that one's definitely wrong. Now, I ask myself when I see an answer like that, why would they pick that? Why would they put that number, such a small number? Because I'm guessing that some students will figure out how much her salary is going to go up, what her raise will be. Maybe that's what her raise will be. And they didn't check that. You don't want to know what her raise will be. You want to know what her new wage is going to be, how much total she makes. That's how much it's going up. So if that's how much it's going up, and I add that to 23,000 and add 3,270, it comes out to 26,270, which is right there. So I could guess that D would be the right answer, because if that's her raise, and some students are going to put down a raise, then the right salary would be this one. I'm just guessing. Well, let's do all the work now to figure it out. Okay, she gets a 4% cost of living pay increase. 4% of 23,000. How do we figure out 4%? Well, you don't multiply by 4. Remember, when they say of, it usually means multiply. But you don't do 4 times 23,000. You have to do 0.04. You move the decimal place 2 places. 4% is 4 hundredths. Percent is hundredths. So 4 hundredths times 23,000. Okay, you multiply that out on your calculator, and you get 920. If you did that on your calculator, 920. That's part of her raise. But she also gets 1% of the total company sales. So you want 1% of 234,000. 1% would be 0.01 times this. If you're multiplying by 100, you could put in your calculator, but it just means you're moving the decimal point 2 places. 100th of 234,000 is 2,340. Now, if you add them up, you get 0, 6, 2, 3, 3,260. Well, that's close to that 3,270. If you add it to the 23,000, you get the 260 and you get the 26,000. 26,260. Very close here. The reason why it comes off a little is the calculators might be using a slightly different computing method, but this is the right answer. They should have had that one. Anyway, that one most closely resembles the correct answer. Okay, moving on. In a recent poll, 3 out of every 8 Food World shoppers said they use coupons at least once a month. If there were 32,840 Food World shoppers last month, how many of them most likely use coupons? Well, you want 3/8 of, means multiply, 32,840. 3/8 is almost a half, by the way. Now, can these answers be correct? Well, these two are bigger than 32,000. How could there be more? 3 out of 8, and that's the total, 32,000. 3 out of 8, that means 3/8 of that. It's got to be way smaller than 32,000. It's almost 4/8, which is a half. Half of 32,000 would be 16,000. So it's got to be somewhere a little bit less than that. Okay, one of these answers, but probably a little bit less. It's one of these two. They're kind of close together. Anyway, if you put 3 times 32,840 divided by 8, because when your 8 is on the bottom, that means divide. You could do 3 divided by 8 and then multiply it. They both will come out with the same answer. They come out with 12150. Is that what I get? 12150, which again is a little off. Oh, actually, I think I made a mistake there. All right, it comes out to 12315. It does come out to 12315. Okay, so plug that in and see, check. But anyway, it comes out to this C answer, and that makes sense. It's a little bit less than 16,000. Okay, so let's look at what we have now for our lesson this week. We've been working with the coordinate plane and linear equations and graphing slope equations. So we've been working with one line, graphing one line, but today we're going to be working with systems of linear equations. So what does systems of linear equations mean? Well, basically, we're going to be working with more than one line. So let me show you. We're going to be working with 2 lines. So if you have your XY axis here, let's say you have your XY axis. Here's your Y axis, remember, is vertical, and this is your X axis, right? Let me switch colors now. So let's say you have a line, right? And remember we talked about how lines are straight line. Lines have an equation that that spell out how the line forms using the slope and the y-intercept. We've talked all about that. So there's an equation that goes with the line, and it involves some y equals so many x plus the y-intercept. Okay, that's one line. But today we're going to be talking about what if you have two lines with two separate equations. So let's say I have another line that goes like this. Okay, so what solving systems of linear equations just means we're going to find a point on this line that fits the equation, but also the point fits this equation. So what we're going to try to find is this point right here, the point where the two lines intercept each other. Now this line might represent some process, and this line represents a different process. And you might want to know where exactly, at what point are both processes satisfied, that a point which is on both processes. Sometimes you have to do that in real world problems. So we're going to be solving systems of linear equations. And there's two ways we're going to be doing it in this lesson. Clean this off. Clean my board. Okay, systems of linear equations. Okay, you can definitely read through this page always before you go on and try to attempt the work, because the page gives a very good explanation of what we're dealing with. Okay, in the first example, what we're going to be doing is we're going to be graphing the lines. We're going to use the two equations that they give us. As for example, here they gave us two different equations. If you graph those two lines and look at where they cross on your paper, on your coordinate plane, you can more or less see about what point is the intersection of those two lines. So that's just by graphing and looking. As you can here, you can see that the points of their intersection is that point right there. I don't know, what is that, 1, 2? 1, 2 would be the answer. Okay, yeah, 1, 2, because the two lines crossed at that point. Problem with this is that it might not be exact. It might be a fractional answer, and you can't tell exactly where it is. So you want a method that exactly tells you where two lines cross. And that's what this solving linear equations we're going to be doing in this lesson, is we're going to be using math to solve where two lines cross. And we do that by using something called substitution. In substitution, we'll set one variable, usually y, equal to some function of x, and then we'll take that function of x and substitute it in the other equation where there's a y, and that should put us down to just one variable. And when the equation only has one variable, then we can solve it. So again, if you have two equations with two variables, you can manipulate them to end up with one equation with one variable. Then you can get that variable. Once you solve for that variable, then you can plug it into your equation and get the other variable. Okay, so what is that all talking about? Well, we'll get to that when we do solve linear equations, systems of linear equations using substitution. So let's go on to our problems then. Make sure you read through this before you attempt. Okay, so first we're going to be working with linear equations, and we're going to be graphing them to try to see where the point of intersection is. Okay, so let's go to number 1. Okay, right there. I'm trying to make that get bigger. I can't do that. Okay, here we go. So we got two equations, and we want to graph each of those lines, those equations, and find out where they intersect. Okay, so do you remember what we need to graph it? We can use the slope, we can use the intercept, or we can just find 2 points that are on there. And the first one you should always do is with x equal to 0. Of course, when you get x equal to 0, you get the y-intercept 3. So when x is 0, y is 3. That's 1 point. Okay, you know what? I'm going to use my pen. It shows up a lot better. It still doesn't look good, huh? Oh well. Anyway, so that's 0, 3. So what else can I use? I can use x equal to 1. If I put x equal to 1, I get negative 5/3. 3 minus 5/3. 5/3 is 1 2/3. So 3 minus 1 2/3 is 1 1/3. So 1 comma 1 1/3. 1 comma 1 1/3 is around there. Okay, so now I'm going to connect those two. Okay, that's one line. Now this line, again, I'm going to use x equal to 0. So y is negative 3. That's the y-intercept, negative 3. How about if I put 3, x equal to 3? The reason I picked 3, because 3 times a third is 1. 3 times a third is 1. So if I do x equal to 3, I get 1 minus 3. Let me put x equal to 3. I get 1 minus 3 is negative 2. So 3 comma negative 2. Oop, I'm almost at the intersection, aren't I? I may have picked the point that is the intersection. That might have been the intersection is 3 comma negative 2. That might actually be the point of intersection, 3 comma negative 2. So I would guess around 3 comma negative 2 is the point of intersection. We just happened to pick a point that was right there at the intersection. Okay, let's try number 2 then. Okay, y is equal to 4x plus 3. Okay, y is equal to 4x plus 3. So, again, I use 0, 0, comma 3. So that's 1 point. The other point, let's use 1. 1, comma, 4 and 3 is 7. 1, comma, oops, it's going to be off. So this is 3, 4, 5, 6, 7. I would say about there. Right? So that's going to go like this. Maybe a little bit higher up there. Up. Okay, now this one. If x is 0, you get negative 2. That one's always easy. Let's do 2. If I put x2, that's not going to help, but I'll do it anyway. 2, that becomes negative 2 minus 2 is negative 4. So 2, what was my first one? It was 0, negative, oh yeah. 2, negative 4 would be there. So now I'm going to get a line that goes like this. What point looks like it's about 1, a negative 1, negative 1. Negative 1, comma, negative 1 is the point of intersection. Negative 1, comma, negative 1. Okay? Okay, did you try this one? Number 3. So if you put 0 here, you get minus 1. If I put, oh boy, let's do 2. Okay? If we put in 2, we get 2 times a half is 1. but it says -1 minus 1, it actually is -2. So 2, comma, -2. Okay, so we got this. How about this one? Well, when x is 0, we get -4. Let's do x4. If x is 4, we get 4 times a quarter is 1, minus 4 is -3. So 4, -3. Oh, -3 is here. Uh-oh, I think I picked the point of intersection, didn't I? They intersect right at that 4, comma, -3. Okay. And number 4, y equals -1. So that's already telling you this line. Y is -1. There is no x, so you just pick y. Here, y is -1. It's a horizontal line. Slope is 0, right? This one is, okay, it intersects at 4. Let's see. If we do y, let's say x equal to 2. Okay, if we do 2, we'll cancel the 2 on the bottom. So we'll say 2, comma. So you end up with -5 plus 4 is -1. 2, -1. Ah! Look at that. I hit it again. Right on the button, I hit the point of intersection. Two -1 is the point of intersection. Okay? Okay, I'm not going to go on. You guys can try these on your own by graphing and finding the point of intersection. Now, if you were given a problem like this, though, however, I would imagine on the high set, where it gave you 2 equations and says, what's the point of intersection? I don't think you're going to graph them. Now, they might show you a picture of a graph, and you have to say where the point of intersection is. But I don't think you're going to be graphing it to try to find the point of intersection. I think you're going to use the next method, which is substitution and working out the math to find the point of intersection. Okay? So we're going to divide this lesson into 2 parts. We're going to have a second part to show you how to do the using substitution to find the to solve a system of linear equations.